Hello everyone, welcome to my YouTube channel. My name is Turgut. I'm going to explain this notebook here. And what is the purpose of this notebook? We are going to use language model and transformers from the Hugging Face Hub. And we will use these transformers as a feature extractor, and then we will train our plan is task classification and also sentiment analysis, and we will use this hidden states of these transformers, and then we will train our own classification based on their hidden states. We will use those hidden states as inputs for our task. So why we are doing this? So the problem in this era is training a huge transformer and language model like this BERT and DistilBERT will be really requires a lot of computation and time consuming. So if our task is if we don't have enough resources, or if we don't have enough the teams to handle this task, so we can use these pre-trained models for as a feature extractor. Then if we are going to do text classification, we can use those hidden labels of this model. So basically, we are going to use DistilBERT here. It's the subversion of the, as the name come from, distilled version of the BERT, Google's BERT model, and it's really powerful. So, and we also have this data set as reviews from the Rotten Tomatoes, and we are going to use data sets, and I leave the link here. And of course, I am going to leave these links as a comments below in my YouTube video too. So here, guys, as you can see here, and I'm sharing my screen, and these are the necessary libraries. And of course, you guys know a lot of them, but I will explain this, which ones are for Hugging Face. This one is for Hugging Face, and this 3 for Hugging Face too. So let's run this cell here. And I'm running this notebook in the Kaggle. It's total of free. You guys can take advantage of it like me. So this is the load data set, and we are going to use ready data set. But in our task in the company or our problem, we need to label our own data set. This is our task. But of course, you can use load data set. How can you use this load data set, our own data set? You can basically just give the location path of your data set and just say which type data set you are using, TXT, CSV, etc. So I'm loading this data set here, Rotten Tomatoes, and let's see how it looks like. This is data set dictionary, and after we read, and this one is contain, train, validation, and test data sets, and this one is contain this number of rows, and we have features, text, and labels. Text are our reviews, labels are whichever person is liked, disliked the movie. If he or she liked the movie, labels are 1. If he or she didn't, labels are 0. So here, let's say look to train df, when you can just take it's a like Python dictionary, you can use as like a dictionary and just put the here train and just take how it looks like part of the data set and train df. And let's look at the first example, and there is a review, and also it's labeled. Okay, so also this datasets object, you can check the attributes of the dataset object here, and it's text, it's value type. Text value type is string. There's no ID, label, and number of classes, name of the classes, negative and positive. And also here, I'm going to set the format in the pandas because I am going to take advantage of the high values of the pandas for visualization purposes here. And it's a pretty basic code. And if you guys know the panda, if you guys know that, you can say the set format pandas and df, and I'm going to use the train data set here, and df head 10, it will show us the first 10 rows in our data set. So I'm going to add my labels to the my data set. I created this as the simple function here. Of course, you can apply basically here as a lambda function too, but I found this, I'm usually creating the function outside. Actually, of course, this is a really basic function. You can use lambda too, but. And basically here, if the label is 0, we are saying return negative. If labels are 1, return positive for that row. And if there's something else, just return undefined. But I know the data set, there is no undefined label here. So what we're applying this function using the apply method here, and it's going to apply this function every rows in our data set, and we will get our result. So let's look at our data set saying df.head, and you can see here we have reviews, this column text, and we have our labels and sentiments positive and negative, of course. And let's see, just do value counts and see our data set is balanced or unbalanced, because it will definitely improve the training process. I can share I will leave a comment. This data set is really balanced data set. We don't have to worry about it, just continue. But if there's a scikit-learn part, and for unbalanced data sets, I will share the link for you guys. You guys can check it. How can you deal with the unbalanced data set? Okay, here, let's look to length of each text here. Because in the DistilBERT, we can only get to 512 token. And 512 token, if our lengths are longer than the 512, that will be truncated, and it will of course affect our model's performance negatively. So here, as you can see, guys, and there's a mostly our just sentence around 20. We can see here this visualization, and longest ones are even less than the 60. That's not a problem, and that means we are not going to lose a performance when we are using this DistilBERT model. So okay, so of course, when we're working with NLP task, we need to first tokenize our sentences or reviews, whatever data we are using, to mathematical representation, which is matrix, because computer doesn't understand the text as we do. They understand from the numbers. So there are, if you're using, like me here, pre-trained model, like DistilBERT or any other model, and these models using they have usually their own, or they are using their own way to tokenizer method. It is really important, because we are not going to train this model. We are going to use this model as a reference, and we were going to send our data and get the hidden state feature and extract them and use it as an input for our classifier. But in here, we are using this, and we are using their own tokenizer, because otherwise, if we use different tokenizer, that will be confused our model and outcome, and the hidden states might be ridiculous, because it doesn't recognize that it doesn't know that we are changed the tokenizer. So you have to, even if you are planning to use different tokenizer, you have to train this model from the beginning, which is we are trying to avoid here. Okay, we are using this tokenizer here. Let's see how this tokenizer works. Basically, this is our example task. This is similar new review here. And okay, so I sent this text to my tokenizer object, and it will return me a tokenized text. Excuse me. So here we have input IDs, as you guys can see here, and also attention mask. What does that mean? So basically, our tokenizer takes out get our tags and tokenize it. Tokenizing is just there are different methods, but it's basically just getting the essence of the word and the sub words usually, because you can't get every word, because it's a problem. Let's say you have great, greatest, greater. There will be 3 different words in your dictionary, and this will dramatically increase your dictionary value when you train a model. And like this, let's say you have 10 hidden states and in the first beginning, and when you multiply this, your parameters increase dramatically, and it will be a problem. That's why we are using tokenizer here, get the subword of the sentence here. So basically, this is the 101 and 102. These are the beginning and the end of the sentence. Tokenizer is just adding for us the sentence that our model will understand. This is the beginning of the word, this sentence, this is the end of the sentence. We also attention mask part. What is attention mask part is doing? If the, of course, we have a certain size of vectors. Let's say, two different vectors we have here for words, and one of them is 10 words, the other one is 7 words, and attention mask will do add for each word 1. If there's, let's say, the 7 word 1 at the rest of the tree to match the other 10 words will be 0. Our model will ignore those zeros when we are training. This is the purpose of the masking, and it's really useful. Anyway, here you can see the how tokenized words looks like. I want you to guys just check out here. Our tokenizer here is just split this word capped and / captivating, just indicating that part. This is the one of the part of the word. This is how tokenizer word, and this is the this is classification for beginning of the sentence. This is the separator. This is the end of the sentence. Our tokenizer adding here. You guys can check out later. I'm going to share this notebook. Okay, so of course we can just after tokenizer converts IDs to tokens. Of course we can use this function. These are all built-in function. I didn't write those. Convert tokens to strings, sending those tokens here to this function as an argument, and just returning back our sentence. Okay, now of course we can just look at how many vocabulary size of the tokenizer. That means our tokenizer have 30,522 vocabulary and tokens. It's different token in its vocabulary. Okay, this is what I'm trying to say before. This is the tokenizer model max length, which is we can send the sentence as long as when they tokenize, not the words, tokenize, their length must be less than this amount or equal to this amount. If we increase, that will be truncated, and it will be loss of performance when we are using the model. So, okay, so what is the input names for our tokenizer input IDs? These are the other attributes of the tokenizer. And this is what we are going to use this function, just adding this tokenizer to every sentence in the word. And we are going to use map method like we used before to do. Okay, here. Okay, I loaded the dataset again because I changed the type to pandas, but okay. Okay, this is implementation. As you guys can see, I'm trying to explain here. This sentence is masked. These parts are 0. This means these parts are masked. Let's say this one. Okay, so tokenize that token. So we were getting this one and showing this one again. I repeated myself here. Sorry about that. So, okay, this is now I'm mapping this tokenized function here. Which is I got from this notebook, guys. This notebooks. Let me show you, and you guys can check it out. It's really good for useful information. Their book here, and thanks to their sharing their data openly, and I really appreciate that. I am taking advantage of it. I recommend to buy their book, and they really explain the Hugging Face environment and with examples. How can you use transformers? Which is a really great resources. I highly recommend it, this book. Okay, I will leave the link for you guys. So here we applied our tokenizer. We set batched true. Basically, this is the thousand, I think the default value is just batching all of them and handling batch by batch. So okay, now after we tokenize, we have new columns. Before we have text, label. Now we have input IDs and attention mask, which what we need for our model. Okay, I take a note here. There are two approaches: employee transfer model, our classification. Yes, one of them is feature extraction, other is fine tuning. I find the fine tuning. I will give an example for fine tuning, not this video, maybe next video in the future. Fine tuning is requires more computation, and you need your own data, and also you have to train model from the beginning. These kind of models are big, and you also need, strong GPUs, etc. But of course, the fine-tuning performance will be, at least in the beginning, it will be better if you do it. So what is, let's continue our notebook here. And we are importing PyTorch here. Probably I did before, but again, PyTorch, this code basically means this is just a PyTorch code. It's just, we were just saying if CUDA is available. If CUDA is available mean is, do you have GPU? If you have GPU, it will basically say you have a GPU, CUDA. If you have a GPU, it says CUDA. If you don't have, you will use CPU. This is not a hard task. I'm just using CPU, but of course, by the way, you guys can just open Declarator here. I couldn't find it, but yes, here you guys can take advantage of the Kaggle's GPUs. These are free, but limited amount of time, but this kind of task, they're just really useful. You can take advantage of it. Okay, I'm just getting my model checkpoint. This is the DistilBERT unseized device. What is our device? CPU, as I said here, and model, we are just taking, okay, auto model is just taking, just how can we get our pre-trained model, and we are putting our device for train, for using. So here, and okay. So here, we were just setting the format, the pandas, and we were just saying the columns here. Why I'm setting the pandas before sending the PyTorch model? Because I am going to use map function again here otherwise we will get an error if we don't choose it. Okay, this is the function. What this function do? This is the, if you guys know the list comprehension, this is the dictionary comprehension, key, torch, key, and v here, key value. What are our keys here? Keys are our column names, input IDs, attention mask. And we are saying that just put our tensors, the values, which is our values, the device, in batch of if they are in the model names. What are these? What are those? We are going to use this input IDs and the attention mask. So we are doing which torch node-RED because we are going to we were just basically not training model, and it will efficient, because if otherwise it will be problematic for us. Not problematic, but it will take more time. We don't need a gradient here, but that's why we are saying no grad. If we don't say it, it will take more time for a little bit bigger performance. Okay, but here, let's look at here. We are using the first hidden states of the first our token. What are those? This token. CLS, our sentence beginning. Why we are using this? First of all, this is the known and mostly used by the data scientists, common practice to use. There are a few reasons. I know that here, and so for example, first hidden states is just has the aggregate representation of the input sequence, and other things are just it's a fixed size, and not unlike any others, it's a fixed size, and just using it is makes sense. Now you guys can read this part. I'm going to continue the notebook here. But the main understanding is in that part is it's just gets the aggregated representation of our input, and also it has fixed position, so we can use it easily. We can, let's say you can't use the last part because which one is going to be last part and position will be confusing. So here, and I'm just, okay, so I don't use GPU here. It will take some time. So basically what I'm doing here, I'm mapping the just extract hidden states function here. That what it does, and okay, it's gonna be really slow. Let me show you real quick how this works, and we can just use our operator here and turn on the GPU. Yes, so we can use GPU now, and we just need to start any other function. Just let's start over. It's not a long process. Sorry about that, guys. I have to just, because this is a really big model, it will take some time to train without GPU. Not train, sorry, it's just even just take extract value without GPU. Let's run these cells. It's smoothing the kernel. Okay. Start it. Is it running? Yes. Okay. Okay. So let's go here. Okay. Now it's going to run this cell too. It's coming a little bit slowly, but it will take time. So basically, we were just mapping this function, and it will just, you know, go every line and just use our model and just get our last hidden state, and we will just return last hidden state as a, you know, a column of our data set. We are using this map function, and you guys will see it soon. Okay, we are reshaping here. This is the output of this is the output shape of our model. Okay, now start running. Okay, 11%. Just a bit wait. Okay, this will be faster, I think. Yes, this one is much more faster. Okay, so now we have hidden states. Now we have our new column names, which is hidden states, as we just, you know, said here. Of course, you guys changed the name here. I just use this function from that notebook. And also, as you can see the shape, I'm just, by the way, why I'm just, you guys can see here, and my hidden state shapes are like this. These are looks like the like just one vector. I'm using the MP we stack function to get the exact shape what I want, like here, because I need to use this shape for the training model. Otherwise, it will be just one vector, and just our values is just, you know, along the way, and just we will see this typing when we look at the shape. Now we have the exact shape what we need. Okay, so after this part, I'm going to just as a show is I'm not going to do any hyperparameter tuning. If you guys wonder how to do it, and I can just show you later maybe, but it's basically we were just importing the logistic regression. It's a really basic model. For this task, I want to show you how this powerful this method is, and we were just saying the max iter method you guys can increase and or decrease, and okay, just let's fit X train in U train and let's go. Okay, let's see. Okay, this is great record, and we are just using those hidden state as an input, and our basic logistic regression model in really short amount of time gives us a really prominent score, which is all right because it's really balanced data. If we can just use scikit-learn dummy classifier, it will be maybe 50-50. But I wanted to show you guys how can you use it, how can you take advantage of it. You guys can use this notebook. As I said, I left the credential for those guys, and I highly recommend buying their books. Thank you so much for watching my YouTube channel. I hope you guys enjoy it. Please leave a comment below, and if you guys want to wonder about deep learning, machine learning, any kind of algorithms in this area, I can explain and I can share my knowledge with you, and I can also learn from your comments. Thank you so much.